orbit number. Orbit is nothing but called orbit but energy shell. Is it something what energy shell, isn't it? That energy shell you are calling as what? Principal quantum number represented by small n, isn't it? So principal quantum number means what actually? It is an energy shell, nothing but orbit number. For example, this is the nucleus. Okay, so orbit like this. There are number of orbits are there around the nucleus actually. This is called actually principal quantum number n is equal to 1, principal quantum number n is equal to 2, principal quantum number n equal to 3. 1, 2, 3, isn't it? 1, 2, 3. So these are the principal quantum numbers. Generally nothing but orbit number. Next, we will see some slides about the principal quantum number now. Who proposed this one? Niels Bohr proposed the principal quantum number. He said nothing but it is a orbit present around the nucleus on which electron revolves. That is called what? Principal quantum number. So which symbol we are using for principal quantum number? Small n is represented for principal quantum number. Now what are the values we can give? 1, 2, 3, 4, 5, 6, etc. we can give. Okay. Next, it determines the size of the orbit. N determines the size of the orbit here. So what is the significance of principal quantum number? If anybody asks you, it determines the size of orbit or shell. Orbit also called shell. Otherwise what happened? Principal energy level. These are the other names for orbit. Principal energy level, shell, orbit, stationary states also we can call, because they are having fixed energy. That is the reason they are called stationary states. So how to calculate the size? So which formula you are using? This is the formula you are using. This formula useful for what? To calculate the size of the orbit. I want to calculate the size, okay, of which principal quantum number? Second principal quantum number. For example, that means second orbit I want to calculate. I want to calculate the radius of what? Second principal quantum number. Nothing but second orbit radius I am calculating. Now what will be the formula? 0.529. Formula in this case, n is equal to what I have to substitute? Tell me. Speak up. N is equal to what here?
Sir, 2.
2. So I have to take 2 whole square divided by, for which atom we are calculating? Assume it is hydrogen. Assume it is hydrogen. Now what I have to substitute here? 1. Then what we get here? 0.529 into 4. Roughly you will get something 2 point something. Okay, no need exactly, something 2 point something angstroms you get here. 1 angstrom equal to how much meters here? 10 to the power of minus 10 meters. 1 angstrom is equal to 10 to the power of minus 8 centimeter. These you need to remember compulsory, because in examination what happened? They ask in terms of meters or centimeters. Most of the case meters only, SI units only they will ask. So you have to remember this one. So in this way you will get some problems also. Calculate the radius of an electron present in the third orbit of helium atom, hydrogen atom. So if they say helium atom, Z value will be 2. Z is nothing but here what? Atomic number. N is equal to here principal quantum number. Already you know this one. Principal quantum, already it is given here. Principal quantum number. Only Z is nothing but what? Atomic number, isn't it? So now it determines the energy of the orbit or shell principle. Not only energy, size we are determining, we are also determining what actually here? Energy also we are determining. We are determining energy also. For that also we are having formula here. This formula is what? This is the formula actually. Okay, this is the formula for calculating energy of electron. I want to calculate the energy of electron present in the third orbit. I want to calculate the energy of electron which is present in which orbit here? Third orbit I want to calculate here. So what we have to do? 13.6. For which we are calculating? See, take hydrogen or helium, whatever it may be. Hydrogen means Z equal to 1. Helium means Z equal to 2. Most of the cases you will get hydrogen or helium, or some cases you will get lithium. Okay. Next, divided by N. N means what actually here? 3 whole square. So after that we are going to get minus 13.6 into 1 divided by 9 something. You will get something 1 point something, 1 point something, isn't it? EV per atom. In this way, you can calculate the energy and what size. So, what is the significance of principal quantum number? 1, we can determine the size, we can determine the energy of electron. Understood here? Now, just I will rub this one so that it will be useful for you. In examination, they are asking this one. What is the significance of principal quantum number? Isn't it? Size and H. We calculate this one. I will just keep this one as in the PPT also. This will be visible for you. So that is the reason I am deleting this one so that it will be easy for you to understand. And energy for this one also I will keep that one, no problem. So n values are always 1, 2, 3, 4. That already we know this one. So next one, next point if you observe here. So we now what we completed until now, we calculated the radius, the size of orbit and the energy of the electron by using the principal quantum number. We already know what is the meaning of principal quantum, nothing but electrons in an orbit is given by which formula we are using to calculate the number of electrons. This is the formula 2n square. The formula we are using is what? 2n square. So for example, I want to calculate how many electrons present in the fourth orbit. Okay, I want to calculate the number of electrons in the fourth orbit, isn't it? I want to calculate the number of electrons in the fourth orbit. This is the fourth orbit. Understood? See, the principal quantum number, if it is 1, its symbol will be K, L, M, N, O, P, isn't it? P is nothing but sixth orbit. O means what? Fifth orbit. What I am calculating here? I am calculating how many number of electrons present in the fourth orbit. Okay. Now n is equal to what here? 4. Now substitute in this one, 2 into 4 square is equal to how many electrons are present? Tell me.
32.
32 electrons. All of you please listen to the class. I will ask the question by calling him also. So I will keep the whatever your attendance register with me, and I will ask questions also. So all of you please listen carefully. So you will have 32 electrons. So this is the formula useful for calculating the number of electrons present in the given orbit, given principal quantum number. So all these are actually number of electrons. Understood here? Right. So just remove this one. Right. As the n value increases, size of the orbit increases. See, whenever n value increases, what happens? Size increases and also energy also increases. So why? Let me see one example here. You do one thing actually. What is the formula for size calculation? See, 0.529 into n square by z. Now substitute the value if n is equal to 1. Then next one substitute n is equal to 2, n is equal to 3. What happened? The radius values will increases. You do this problem. Similarly, substitute the value for the in the energy minus 13.6 into z square by 9 n. Substitute the values, energy will always increase. I will show this one. You take again this slide here. See, you substitute this, isn't it? N values here 1, 2, 3, 4, 5. Then what happened? The values will increases here. Same what happened? You substitute the n values here. What happened? The values will increases here. But actually, what happened? Why will take this minus value to show that value increasing here? So somebody will ask definitely why you are using the minus here. Why you are using the minus here? So why? Because actually to show the energy of the electron is increasing. So that is the reason generally we'll take the minus value here. So these are the also most important one. The size increases. That means what happened? The radius directly proportional to the n principal quantum number. As principal quantum number increases, the radius value also what happened? Increases. As the n value increases, energy also what happened? Increases. So energy of electron, radius of orbit always directly proportional to what here? Principal quantum number, isn't it? This you need to remember. The angular momentum of the electron is given by, already this we discussed in the Bohr's model. Angular momentum MVR is equal to NH by 2 pi. So in this also what you are getting, N is nothing but your principal quantum number. So with the principal quantum number, we can calculate what? Angular momentum of electron. When you substitute the H is common. H is a Planck constant 6.6 into 10 to the power minus 34 joules. That is a common for any electron. Pi is equal to 3.14 is also common for any electron. Now what is the variability here? Principal quantum number. As the principal quantum number is changing, angular momentum of electron also will change. So angular momentum of electron is also directly proportional to what? Principal quantum number, isn't it? So remember these formulas and the orders also. We will get in the MCQ questions like this type of questions. This is about the principal quantum number, right? Next we'll see the azimuthal quantum. This is the second type of quantum number, azimuthal quantum number. Principal quantum number is the first one. Azimuthal quantum number is the second one. Let me see what is this azimuthal quantum number. Now, it is represented by small l. It is represented by small l like this here. And who proposed this one here? Sommerfeld. Sommerfeld proposed this azimuthal quantum number actually. Next. Now, it denoted first by actually k. First it is denoted by k, but k we are using for what actually? Principal quantum number is equal to 1. So later it is modified by L. This is no need for you, but to explain that one, I will take in this one. No need for you. Just remember, you just leave it this k value. Okay. So remember L only. Okay. Right. Now L is equal to always what happened? K minus 1. If k cannot be 0, while L can be 0. So actually you do one thing actually. You instead of taking the k, you better to take this one N. Okay. Better to take this one as what? N now. We will get some problem there. N. Okay. L is equal to N minus 1. Actually k is correct only, but you will get doubt. K is what? Is always will be 1 only, no. So why we are taking only k only? Why not L and N? L also you can take, M also you can take. So simply L is equal to N minus 1. If I say L is equal to N minus 1, then you will get definitely. Now tell me, is it possible N is equal to 0 is possible? Tell me, N is equal to 0 is possible?
L can be 0. Yes, sir.
No, N is equal to 0, is it possible?
No, sir. No, sir.
No, definitely. N is equal to 0 means you don't have any orbit.
No, sir.
If somebody has 0 rule number, is it possible? In your class, what happened? Somebody got something, Chaitanya got something, what happened? 0 rule number. Is it correct? No. Should have 1. You got to start from 1 actually. No? So you take here also what? N only. Divide the actually k you can use, but N you use actually. Okay. N cannot be 0, but L can be 0. Why? Because you substitute 1. If N is equal to 1. If N equal to 1 means what? First orbit, right? If N is equal to 1 means first orbit. Now substitute in this one, L will be what? Definitely will be 0 here. So L can be 0. This type of questions will get in the MCQs. Following which is correct option, wrong option. Like that they will ask. N cannot be 0, but L can be 0. Definitely it will be 0. I will explain why it is 0. I will explain the next step. It will come. But you just remember L can be 0 also, but not negative. It will be start from 0 onwards, right? This is the main important point you need to remember. Next, if you observe. It's also known as orbital angular momentum or subsidiary quantum number or secondary quantum number also we can use. Generally we'll use this, is most of the cases we'll use orbital angular momentum. Why? Because this azimuthal quantum number explains about the orbital, not orbit. Explains about the orbital where actually electron present. So that orbital that we see now. Okay. Secondary quantum number, the subsidiary quantum number, that is generally we don't pronounce that one most of the cases. So we'll see azimuthal or orbital angular momentum. Generally we'll see this. Let me see that one. Now this is very important. L value depends upon N value. If you know the N value only, we can write L value. If you don't know the N value, it is impossible to write the L value. Why? Because L is equal to what here? N minus 1. That means L always depends on what here? N value. Without N value, it is impossible to write what? L value. They're interdependent. All these quantum numbers are interdependent. So if you know the n value, then only we can write the L value. Next. L value ranges from 0 to n minus 1. This is also important one for us. L value ranges from 0 to n minus 1. For example, if n is equal to 4. Now what will be the n value, anybody? If n is equal to 4, what will be the L values? L is equal to what should be the values maybe?
Sir, 3.
What are they? Based upon this formula. Tell me. Based upon this,
3.
3.
Sir, L equal to 3.
no. Based upon this formula, 0 to n minus 1 means 0. 3 is correct only.
1, 2, 0, 1, 2, 3.
Comma 1, comma 2, comma 3. There are 4 L values we get here. Okay, 4 L values. But start from where? 0 to 3. Why? Because L value is always equal to n minus 1. So substitute here 4. 4 minus 1, 3. So L values we get up to 3. What I mean to say, L values we get up to 3. Starting from where? 0. Starting from where? 0 to 3 we get. For example, n is equal to 6. That means L values we will get what? Up to 5 we get. Starting from 0 to 5 we get here. Total 6 we get. But what I mean to say is that here, the total L values starts from always 0 to n minus actually, isn't it? This is, you need to remember. This is also important one. Next. Right, tell me.
Sir,
Speak.
what the L value gives us?
Yeah.
सर L का जो वैल्यू है वो हमको क्या बताता है?
वो आते हैं बेटा, वो सारी चीज आते हैं, जल्दी थोड़ा वेट कर दो। ये एल वैल्यूज होने के बाद मैं बताऊंगा क्या एंगुलर मोमेंटम क्या हो जाएगा, वो सब मैं बताऊंगा आपको।
ओके सर।
You observe here, if n is equal to 1, what is L value? Only 1 we get here. That is what? 0. Only 0 we get here. Next, if n is equal to 2, what we get? 0, comma 1. 0, comma 1 we get. Total values will be 2 only. If n equal to 3, 0, comma 1, comma 2. If n equal to 4, 0, comma 1, comma 2, comma 3. Isn't it? So these are the things we get in examination. In examination, they are asking this type of questions. If n is equal to 4, L values are first option something 0 to 1, 0 to 1 to 3. In this way, they are asking. Very simple to remember. Okay. So the L and n value. That means in the last slide you have this. We have just now completed that. L depends upon n value. L depends on n value actually, right? N value, isn't it? So this is the important for problems. Next, L value denotes the sub level in main energy level. I told you now orbital itself. Orbit, not orbit, I'm saying orbital. So energy level, each energy level, each orbit, each shell will have subshells. Okay, a shell or energy level will have a subshell. That subshells we are calling as what? Orbital. We are calling as orbital. Orbital. Shell is called nothing but here orbit. Orbit. Orbit is different. Orbital different. Orbit means what? Anybody, what is orbit? What is orbit? Anybody?
The path on which electron revolves.
The circular path on which electron.
The path on which electron revolves.
Nucleus, right? Now, what is orbital means? Anybody? In the last class,
Yes.
probability of finding the electron maximum, that is 95%. That is called orbital. If you watch that last video, you will get what is orbital. Nothing but it is psi square. Probability of density of electrons, psi square. We discussed in the last video. I uploaded it on YouTube actually. The probability of finding the electron is maximum, that is 95%. So for example, this is the radius. This is the radius. But the electron probability are observing this one. This is the probability of electron is here. So now this is called what here? Orbital. Because here only the probability, here also electron probability is there, because electron always revolves. No, when it is revolving, what happened? Here only one electron, something actually you are observing here, something like. But here you are getting what? More amount of probabilities are observing. The position of electron here observed here. Okay. Now, so just now somebody asked the question, what is the use of L value? So it always denotes the orbital sub-level in the main energy level, isn't it? Sub-level in the main energy level, orbital in the main energy level. Orbitals are again further divided, that will get in the magnetic quantum number. Okay. Right. Next. Now, if L is equal to 0, we are saying L is equal to 0, L is equal to 0. What is the meaning of L is equal to 0? Nothing but S orbital. L is equal to 0 means is S orbital. If I say L is equal to 1, P orbital. If I say L is equal to 2, D orbital, F orbital, G orbital. So actually, we are not using this G orbital. Generally, we use up to F orbital. So according to our periodic classification or periodic table, we have up to only F orbital only, isn't it? If L is equal to 5, H sub level actually, right? If L is equal to 5, H sub level. In this way, what happened? We have. Now, what I mean to say, for example, if L is equal, for electron is there, that electron L value is 2. I'm saying what? Electron L value is 2. I say like that. If electron is having L is equal to 2. What is the meaning of that one? This electron present in the d orbital. You can say like this, isn't it? Now somebody say something what happened like this. Something what happened in your class, some Vaishnavi is there. Then she is staying in room number 202. She is staying in room number 202. That means what happened? She is staying in second floor. Okay, she is staying in second floor like that. So the position we are saying here, I told you in the just now, we are just discussing the address of electron. Quantum number is nothing but address of electron. Don't write in examination address of electron is called quantum number. So that is not correct. But I want to explain things. I told the example called address. So when you say what happened, address of electron L is equal to 2 means what happened, on which orbital electron is located. The electron located in d orbital. But d orbital further classified. That will get in the magnetic quantum number here. So here, electron now present in d orbital. If it is having L is equal to 2. For example, if I say what happened, electron L value is what? 0. What you can say? The electron is present in which orbital? It is present in the s orbital. You can say the electron present in the s orbital. So this is the use of what actually? Azimuthal quantum number. In which orbital the electron is located. That can be explained by the location of the electron, isn't it? Actually by magnetic quantum number, but anyhow we are saying that which orbital it is at. So this is about the L values, isn't it? 0, 1, 2, 3. This is you need to remember. Up to F you have to remember, isn't it? S orbital, P orbital, D orbital, F orbital, isn't it? These things you have to compulsory remember actually. Next, sublevels distribution based on the n plus L rule actually. Let me see this one now. N is equal to 1 means first orbit, second orbit. Now second orbit contains what are the orbitals? First we will complete this one, later we will take it. Just a minute. Now this will be what? Now n is equal to 1. If n is equal to 1, now which orbital you are going to have? Only one whole orbital. What is that orbital? S orbital. Now in second orbit, in second principal quantum number, which orbitals we are going to have? Anybody?
SP.
What are L values? 1 is what here? Now in this case L is equal to 0, 1. In this case L is equal to only 0. Now tell me which orbital is present here? Speak out.
2s and 2p.
Yes?
2s and 2p.
Yeah, right, very good. 2s and 2p orbital, isn't it? 2s and 2p orbital. Now n is equal to 3. L values will be what here? 0, 1, 2. L 0 means S, yes. 1 means which orbital? P orbital. 1 means P orbital. D means what? D orbital. Now tell me which orbitals are present here? Here, which orbital will be there here? Here.
3s, 3p, 3d.
3s, 3p, 3d.
Here it is 3s.
3s, 3p, 3d.
3p. And here it is? Here it is?
3D.
Very good. So here it is 3D. Now this one will, why it came, we discuss that one later. Why we got here 4s, that we discuss later. Okay, right? Based upon energy here. Next, for the fourth, L is equal to what? 0 comma 1 comma 2 comma 3. Now L is equal to 4. No, we can call this one 4s. We can call this one 4p, 4d, and 4f. Now we can write here what? 4s already we got here. This is coming from where? 4s is coming from where? Here, from the fourth only. So why we got here, I will discuss in the which rule actually? Avogadro principle rule. I will explain this one. Why 3D is having more energy than the 4s? Because of the values. 3 plus 2 is equal to 5 we get. 4 plus 0 is equal to 4 we get. That is different actually. So 4p, 4d, and 4f. So this is very, very important. It looks very simple, but when it comes in examination, what happens? You are making many number of mistakes. Very simple to write here, based upon the formulas here. Everyone understood here? You have any doubts now? Anybody?
Yes, sir.
Speak out.
No, sir.
After completion of the class, don't say what, sir, what is principal content number? I didn't understand, sir. Sir, please tell me, sir, what is principal content number? You can't ask like that. After finishing the topic, you can't. If you have any doubts, you can ask me. Meanwhile, in the class going on, you can ask that. After complete finishing, sir, I didn't understand what is S orbital, sir. Why you are writing here 4s, sir? I'm not understanding, sir. Why you are writing 4s, sir? And why you are writing here 4d, sir? I'm not understanding. So you follow my class, definitely will understand. Otherwise, even though if you don't follow what happened, you can ask some questions, isn't it? I think everyone understood this one. How to write? If they given n is equal to 5. Isn't it? What we can write here? 5s, speak out, 5s, 5p, 5d, 5f, and 5g. But g is not there. So generally g is not present up to now. Maybe come in next coming years also, they may come g orbital also. Because we are having up to only 118 elements. So if we get 119 element, this is possible. Okay, leave it this one. And we will move to our next slide now. So you are saying what, sir? S you are using, P you are using, D you are using, F you are. What is this SPD? Why can't you start from A, B, C, D? You know, you are already all familiar with A, B, C, D. So A for apple, B for bat, C for cat. We know that one. D for tag. We know that one. So why don't you use what A for apple like that? Why you are using S, P, D, F, G only? Because these comes from the spectroscopic terms. In which what happened? S for sharp, isn't it? S for sharp, P for principal, D for diffusion, and D for what? Fundamental. From there only they derive this one. F derived from the fundamental, D derived from the diffusion, P derived from the principal, S derived from the sharp actually, isn't it? So these are the spectroscopic terms. In examination, nobody asked this one. So leave it this one. If you get any doubts, you can just see this one. Now, when n is equal to 4, L is already with this one, 4 values here. Just now we completed this one, everything. So n is equal to 1s orbital. N is equal to 2s, 2p. N is equal to 3s, 3p, 3d. These are sub-levels. Remember, these are all sub-level. Level means what? Orbit. Understood? Principal quantum number. Sub-level means nothing but what? Azimuthal quantum number. Sub-level is nothing but called Azimuthal. 4s sub-level actually. N is equal to 4s, 4p, 4d, 4f. These are very, very fundamental things actually. To write the electronic configurations, these are the very, very important fundamental things actually. The number of L values is equal to magnitude of N values. That already computed. The energies of various sublevels in energy level SP. Generally what happened? Which will have highest energy? G. So S energy is lesser than the P. P is having less energy than the D. D is having less energy than the F. Isn't it? This is also important one. Energies. It tells about the shape of the orbitals. So what is the significance of the Azimuthal quantum number? Shape of the orbitals. So for example, S orbital generally will have spherical shape. P will have here dumbbell. S is having what here? Isn't it? Spherical shape. I'm writing. Spherical shape. S is having this shape, spherical like this. And D, P is having dumbbell shape. Dumbbell like this. Isn't it? D means what? Double dumbbell. 2 times will take. 1, 2 times. Double dumbbell. Isn't it? And F is adding taking what? 4-fold. Quadra means what? 4-fold dumbbell. 4-fold dumbbell shape. Quadra means what? 4. 4-fold double dumbbell shape. 4 times you have to take. 1, 2, 3, 4, 5, 6 like this. 1, 2. But that is generally nobody asks this one, so leave it this one. So generally we get these are the in examination we are going to draw the shape of s orbital, p orbital, d orbital, like that they will ask you. So what is significance here? It explains the shape of the orbitals here. Shape of the orbital, which shape it is having, isn't it? Remember this shapes: spherical, dumbbell, double dumbbell, and 4-fold dumbbell shapes. Very, very important one it is. Next, the orbital angular momentum is given by. So we have discussed actually what angular momentum of electron present in the given orbit. That is different. MVR is equal to NH by 2 pi. NH by 2 pi. This is the for orbit actually. For the orbit. The principal quantum number it is. Now this one is what? For orbital. Just differentiate this one. Orbital is different. Orbit is different. Okay. For that one, the formula will be mu is equal to root L into n plus 1h. So you have to substitute the L value. For example, if L is equal to 0, what will be the orbital angular momentum? Isn't it? Let me see this one. Bm is nothing but Bohr magneton, and value will be what? 9.2. This 1 Bm is equal to what? 1 Bm is equal to 9.2 into 10 to the power minus 24 joules per Tesla. This is nobody asks in examination. Leave it this one. In examination, nobody asks this one. An extra syllabus one. Now put L is equal to 0 now. I am putting L is equal to 0 here. Now what happens? You will get the 0. The orbital angular momentum will be 0 here. Right? Next. 2p, 3p for example. For 2p, L value will be what here? 1, right? For the 2p, this one. P will be what? L is equal to here? 0. For any p orbital, observe here. For any p orbital, it may be 2p or it may be 3p or it may be 4p or it may be 5p. Its value will be substitute here 1. 1 into 1 plus 1, that will be what? Root 2h. So this is the value for us. H by root 2 pi. This is the value. For any p orbital, 2p, 3p, 4p, 5p, 6p, whatever it may be, isn't it? Its orbital angular momentum will be h by root 2 pi. Okay, for any 1s orbital, 2s orbital, 3s orbital, the L value will be here what? 0. And here also it will be 0. For any 2p, 3p, 4p, 5p, L is equal to 1, and orbital momentum of electron, orbital angular momentum of electron will be h by root 2 pi actually, isn't it? Next for what? D orbitals. L is equal to 2. For all d orbitals, for any d orbitals, L is equal to 2, and its value will be substitute L value here what? 2 here. This one is 1, isn't it? So you are going to get this is the things. Maximum number of electrons present in a subshell or sublevel is given by 2 into 2L plus 1 or 4L plus 2. So now what is actually here saying here? I want to calculate how many electrons in the given subshell. This is the formula you can take. Somebody asked you how many electrons are there? How many number of electrons are there in D subshell? In D subshell. Anybody, how many electrons will be there? How many electrons are there in the D subshell? Now what is the formula you have to take here? You can take either this formula or this formula. I am taking this formula, is very simple. Or this formula also you can take it. 4 into, I am taking this formula. 4 into, what is the L value for D? L value for D, L is equal to here what? 2. Now substitute here 2 and plus 2. Okay, first you multiply 8 plus 2, that equal to how much here? Number of electrons will be here? 10 electrons. So this formula is very, very simple for us. We calculate the number of electrons, isn't it? For example, s orbital, number of electrons will be 2. For p orbital, number of electrons will be 6. For f orbital, number of electrons will be 14. How you say? Based upon this formula, by just substituting the L values. L is equal to 0, L is equal to 1, L is equal to 2, L is equal to 3, like that. So in s orbital, all these we get now here. L is equal to 1. Which orbital it will be? P orbital. P orbital. So after substituting the formula, we are getting 6 electrons. If L is equal to 2, p orbital. The number of electrons we are getting after substituting in the formula 10. Okay. Next, if L is equal to 3, f orbital. The number of electrons we are going to get here 14 by substituting in the formula. You need to remember the formula only. L is equal to 4. Like that you will get here. G orbital will have 18 electrons. In this way, we will get all these things actually. So just you need to remember the formula. Next, we'll move to what third quantum number called magnetic quantum number. Third one is called what? Magnetic quantum number. Now, what is magnetic quantum number? Let me see. This is the last one for representing the electron. One more will be there. The fourth one, spin quantum number, that is different. Magnetic quantum number represented by ML. This is actually not one actually. This is ML. It is L. Subscript it is. The subscript is nothing but what? LL. Right. Now, who proposed this one? Landé. Landé proposed this quantum number called magnetic quantum number actually, isn't it? Proposed by Landé. Now, what explains here? Now, it denoted by ML. Just now we see this one, L it is. Not, it looks like one, but it is what? L only. Right. Describes the orientation of orbital. Orientation of orbital with respect to coordinate axis in space, with respect to x-axis, with respect to y-axis, with respect to z-axis. That means in which space orbital is there. Orbital is oriented on y-axis. You can say something. P orbital is oriented on x-axis. You can say something. P orbital is oriented on z-axis. That means magnetic quantum number describes the orientation of orbital with respect to coordinated axis like x-axis, y-axis, and z-axis. Okay, where it is oriented, which on which position it is oriented, that explains actually. Now also it explains Zeeman effect. So we have one limitation in Bohr's model. One of the limitation of the Bohr's model. In examination, they will ask, write the limitations of the Bohr's model. Like that, you will get question. One of the limitation is called Zeeman effect. Can anybody say what is Zeeman effect? Already we completed that one. Zeeman effect completed. In Bohr's model, we completed the Zeeman effect. Anybody? Are you there? Nobody is there now. Zeeman effect. Yes.
So splitting of spectrum lights.
Splitting of spectral lines under magnetic field. That is called what? Zeeman effect. Splitting of spectral lines under electrical field is called Stark effect. So this is explaining the Zeeman effect. A line splitting into what? Several lines here. This is explained beautifully by the magnetic quantum number. Let me see what is this, how it is explaining the Zeeman effect. Now let me see this one. So this is the definition. The splitting of a single spectral line. This is a single spectral line, isn't it? This is a single spectral line splitting into number of closely spaced lines like this. It is splitting into closely lines. Under which field? Magnetic field. This is important for us. That is called what? Zeeman effect. Let me see the Zeeman effect, how it is explaining. Now, the total number of M values, how many magnetic quantum numbers will be there for each L value, that can be explained by the 2L plus 1 formula. So you are getting many number of formulas, you know, 2N square for what? Number of electrons. 4L plus 1 what? For number of electrons per orbital. Now 2L plus. There are number of formulas you are getting. So you write all the formulas in notebook, what happened, to understand easily. Okay. So this formula, isn't it? For what purpose we can use? To calculate the total number of M values. Actually, no need these formulas. You will get easily. Very simple. You can write that one. Now, total number of M values, if they give L value, that means M magnetic quantum number is depending upon L value. If you don't know the L value, then if you don't know this one, you can't write the magnetic quantum number. So they are interdependent. Now, when L is equal to 0, When L is equal to 0, what formula you have to use? 2L plus 1 formula we have to use here. Now L is equal to 0 you put here. Now how many values will get? Only one value we get here. Now when L is equal to 1, now put in this case L is equal to 1 here. Now how many we are getting? 3 values we are getting. Now if L is equal to 2, now put here 2 here. Now total values we are getting 5 values here. If L is equal to 3, put here 3, you are getting 7 magnetic quantum numbers here. L is equal to 3 means what? Which orbital it is? L is equal to 3 means which orbital it is?
F.
F orbital. For F orbital, how many magnetic quantum numbers will be there here? 7 magnetic quantum numbers. For D orbital, how many magnetic quantum numbers will be there? 5 magnetic quantum numbers. For P orbital, how many magnetic quantum numbers will be there? 3 magnetic quantum numbers. S orbital, how many magnetic quantum numbers are there? Only 1 magnetic quantum number. So this is the formula we are using actually. Now, no need to remember this formula. See, you take odd numbers. 1, 3, 5, 7, 9. Then 9 after that, 11. 11 after that, 13. Very simple, no? So formula no need to remember. See, first one will be 1. Then second one will be 3. Then 5, second. We can easily understood that one. So no need to remember, because remembering too many number of formulas is what very difficult for us. Isn't it? So in examination, what they ask, what happened in D orbital, you have how many magnetic quantum numbers? Simply you say what happened? 5 magnetic quantum numbers we are having. Now, what are these 5? What are these 3? What are these 1? What are these 7? How to write these 7 magnetic quantum numbers? How to write the 5 magnetic quantum numbers? Let me see now. N is equal to 4. This generally we don't see this one, so no need to remember this one. So this is no need for us. M can values based upon the L value, that can be what? Minus L2 plus L. So minus L2 plus L. If anybody asks you write magnetic quantum numbers, you have to write based upon what? L values. You have to write from based upon L value, that will be minus L2 plus L. Let me see what is this minus L2 plus L. Now when N is equal to 0, right? Now M values will be definitely also what happened? 1 only. That will be what? 0. Now minus 0 to plus 0 means what? Only 0 only we get, right? Next. When N is equal to 1, how many values we get already? 3 values we get, right? We get 3 values. Now how to write these 3 values here? You have to take this formula. You have to take this formula. Minus L2 plus L. L is equal to what actually? 1, right? Now put here minus 1 to plus 1. Now what we get here? Minus 1, 0, plus 1. Total how many we got here? 3 M L values we got here. Okay. For example, if N is equal to 2, for example, L is equal to 2. Now what we get here? Minus L2 plus L. Means what you have to write here? Minus 2 to plus 2. Now if L is equal to how many values we get here? 5 values, right? 5 magnetic quantum numbers we get. What are they? Minus 2, minus 1, 0, plus 1, plus 2. So total how many values you are getting here? 5 values you are getting. In this way, we can write all the magnetic quantum numbers. You see all these things here? Now, see, this is a practice for you. You will get in the next slide everything. All these values will get in the next slide. Okay. So this is the very, very important. Now, next, this is what? Orientation. Okay. This magnetic quantum number explaining what? Orientation corresponding to one orbital. That orbital is oriented how? Whether in x-axis or y-axis or z-axis. That we see now. Now if L is equal to 1, okay, removing this one, display this one, just will remove this one. Right. If L is equal to 1, so which orbital L is equal to 1? P orbital, P subshell it is. M will have 3 values. They indicate what? Minus L, isn't it? Isn't it? Minus L to plus L. That means what actually? Minus 1, comma 0, comma plus 1. Now, the orbital is oriented in three-dimensional space with px orbital, py orbital, and the pz orbital. That means the electrons present on the z orbital, then it is what? Pz orbital. The electron present on the y-axis, that is called the pi orbital. The electrons present on x-axis, then it is called px orbital. So three values are present for which one? P orbital, and L value is equal to 1. So px, py, pz. Now for -1, 0, +1, where we need to take it? Now, whenever m is equal to 0, that 0 we get, that will be always z only. Now, for +1, -1, you can take x here. So that means this will be what orbital here? Pz orbital. It may be px. If it is px, it will be py. If it is px, it will be px actually. So now, -1. For example, I will say something. An electron is having, I'm writing it. If electron is having ml is equal to 0. Now what you can say now? Anybody? Electron magnetic quantum number is equal to 0. Now what you tell based upon this? Anybody speak out? Speak out, otherwise I will close this one.
Is oriented on z axis.
Very good. That electron is oriented. First of all, you say something. See, the electron is present in the p orbital, which is oriented in z axis. Okay, which is oriented in z axis, right? So this is the way you can easily answer like this. Now let me move to next slide here. Now if L is equal to 2, now which orbital in L is equal to means what? D orbital. Now it will have 5 values. What are they? Isn't it? 5 values. Each value indicates what? Each orbital actually. Based upon their orientation in the three-dimensional space. Now L is equal to what values they are going to have? Minus L to plus L. Okay. Now L is equal to here what? 2. Now put here -2 to what? +2. Means what we get? -2, -1, 0, +1, +2 values. There are 5 d orbital. Now how they are oriented? Let me see here. dxy, dyz, dxz, dx square y square, dz square. Because it is double dumbbell shape. So xy, yz, x square, y square. Now I told you, whenever you get z, take 0 only. Whenever if you get 0, that you always take as z only. If you get 0 value, that always for what? dz square. This is for dz square. Remaining xy means you can take +2 or -2. Okay, you can take +2 or -2. Yz means, isn't it? You can take this one as like this. I'm writing here -2, -1, 0, +1, +2. This always will be dz square. Okay, -2 means I can take dxy. -1 I can take dyz. Next +1 I can take dxz. +2 I can take dx square y square. I can also take like this also. This +2 I can also take dxy also. Okay. Next similarly what happened? This -1 I can also take as a dxz also. Similarly the dxy I can take even not dxy. This one +2 dx square y square. Similarly dxz. Okay. Now -2 I can take as dxy or dx square y square. +2 means I can take dx square or dxy. -1 means I can take dyz or dxz. So very simple, isn't it? This is explaining the orientation of the orbital. To avoid the confusion, see, take this one what? Like this. To avoid the confusion, take -2, -1, isn't it? This one 0. This one will be +1, +2, isn't it? Isn't it? Like this you can easily take it. Otherwise, if you have any difficulty, if you don't understand what happened, I will show very simply like this. So what is this actually? -2, comma, -1, 0, +1 and +2. Very simply, let me see. If anybody has doubt like this, 0 always will be dz square. No question about this one. You take this one as a dxy. Then it will be dyz. This will be dxz. This will be dx square y square. Finished. Finish. This very simple here. So in this way, what happened? We can write all the magnetic quantum numbers. If you have any doubts, again you watch the video. I will put this video on YouTube. I am recording this one. I will put in the video, and I will even send the PDF format also. When F is equal to L is equal to 3, that will be F orbital. We get 7 magnetic quantum numbers, -3 to +3, like this. -3, -2, -1, 0, +1, +2, +3. This way we are going to get 7 values. Okay. F subshell will have 7 orbitals here. Okay, it will have 7 orbitals. Okay, all of you understood now, no? S is having 1 orbital, that is 0. M value will be 0. And P is having 3 orbitals. M values are what? -1, 0, +1. That is nothing but Px, Py, Pz. And L is equal to 2. Here, that is nothing but d orbital. M values will be 5. -2, -1, 0, +1, +2. Nothing but dxy, dyz, dzx square, dxz, dx square y square, and dz square. These are the orbitals actually we are having. Okay. Now we'll write in the graphical representation like this. F sub orientation. Generally, F subshell is not there in the syllabus. You can just leave it this one. F orbital, you can leave it this one. No problem for this one. Then there are 7 orbitals will be there, like 1, 2, 3, 4, 5, 6, 7. It's also no need for you. Total number of orbitals in the energy. Now, how is the formula to calculate the number of electrons? Total number of electrons.
2n square.
What is the formula for calculating the total number?
2n square.
N square. That means take half of the formula. You take n square, isn't it? So calculating the number of electrons in orbital, formula will be 2n square. Now for calculating the number of orbitals, the formula will be n square. That means each orbital will have only 2 electrons. You can write only 2 electrons in a given orbital. So for example, n is equal to 1. Okay. So that case, how many orbitals are possible? Only 1s orbital is formed. If n is equal to 2, we can write 4 orbitals. That is 1s orbital and 2s orbital. Then actually what happened? 2p orbital, isn't it? But yeah, this is no need for now. Sorry. N is equal to 2p orbital, sorry, 2s orbital, and what happened? 2p orbital. Now 2s will have only one value, 2p will have how many? 3. 2p will have 3. Total is equal to how many here? 4 orbitals we are going to have. Because one is what? Z, x, and what? Px, Pz, and Py. Otherwise, 0, -1, +1. Okay, total how many orbitals are getting? 4. Now n is equal to 1s, 2s orbital, and 3, 2p orbital. See, 3 are 2p orbitals, 1 is 1s. If n is equal to 3, we are getting 9 orbitals. We are getting here. 9 orbitals. Okay. Now 1 from the 3 orbital. So 3s, 3p, and 3d. Okay. In 3s, 1 orbital. 3p is again what happened? 3. 3d is again what happened? 5, like this. 1, 2, 3, 4, 5. This one will be px, again py, pz. This one will be dxy, dyz, dzx, dx square y square. This one will be dz square. This value will be 0, -2, minus, other way you write something. You write like this here. You put your 0 here, +1, +2. Okay. This will be dz square. This will be dx square, y square. This will be dzx. In this way, we can write how many? 9 orbitals. From here, 5. In this 3. In this 1. Total what happened? 9. Similarly, for n is equal to 4, 16 we can write here. That means what we can write here? 4s, Then what happened? 4p, 4d, and what happened? 4f. From here 1 in this 3 like this. In this 4d, 1, 2, 3, 4, 1, 2, 3, 4, 5, 4f. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay, like this. 0, minus 1, plus 1. 0, minus 2, minus 1, plus 1, plus 2. 0, minus 3, minus 2, minus 1, plus 1, plus 2, plus 3. In this way, we can write all these orbitals here. Understood? How to write the number of orbitals if they given the energy level, principal quantum number if they given, you can write easily the number of orbitals here. Now, if I say something, what happens? Psi 1, 4, comma 2, comma 0. What is the meaning of this? In examination, they will give like this only. Okay, they are giving in this manner only. Psi 4, comma 2, comma 0. Psi is nothing but wave function. The wave function represents the orbital of electron. Okay. Now, first will be n value. This will be L value. This will be L value. This will be M value. Okay. Psi 4, comma 2, comma 0. Principal quantum number is 4. Azimuthal quantum number 2. Magnetic quantum number will be 0. So, which orbital it is? 4. L is equal to 2 means which orbital? L is equal to means which orbital it is?
D.
D.
D orbital. Now, M is equal to 0 means which orbital?
S.
M is equal to 0.
Yes.
D z square. Now, you can say psi 4, comma 2, comma 0 indicates the electron present in the 4dz square. Simply, we can say the electron present in which orbital? 4dz. As I already told you, for d orbitals, m equal to 0 means you have to take dz square. In this way, we can easily NLM denotes an orbital in the case. So it is nothing but what? 4dz square. Right? Different n values for given L value provides the total number of ways in which SPDF presents in the magnetic field. I will give one more question here. Psi, very simple question I am giving for you. Psi 3, comma 1, comma 0 you take. Okay. Next. Same. Psi 3, comma 1, comma you take what? 1. Now tell me. Now tell me here which orbital it is. Speak out all of you. Which orbital it is?
P.
So
Yes?
3p z square.
3p z only. Z square not there in the p orbital. 3p z orbital it is. Okay. Now for this one, this is same.
3px.
3 for principal quantum number. Write down 3. This is L value. L is equal to 1 means I have to take P. Now 1 means it may be plus 1 or minus 1. If it is plus 1, it may be Px or it may be 3Py. Anything it is possible. Anything it is possible. 3Px or 3Py. We can't say that. Okay? Understood my point, what I am saying here?
Yes, sir.
Right. Magnetic quantum number also represents the quantized value of z component of angular momentum of electron in orbital through the expression. This is the expression. Generally, you don't need this one, so leave it this one. This is not for your. This will come in higher standards actually. Leave it this one. It's no need at all for it. Now, can you say what are the magnetic quantum number values for 3s, 4s, and 5s electron? What are the magnetic quantum numbers?
0. 0, 0, 0.
0, 0. All are having what? 0 values only. Therefore, all are having 0 values only. Very simple thing it is. Now, what is the M value for PZ, BZ square, and FZ? FZ3. PZ means always anywhere you take Z. Z indicates
0.
M is equal to 0. This is very simple to understand here. As Z is equal to 0, we'll get M is equal to 0 only. Now, last quantum number, let me see. Spin quantum number. See, actually spin quantum number does not say the position of electron. The position of electron can be calculated by which quantum numbers? Principal, azimuthal, and magnetic quantum number. These three denotes the electrons. How to denote? How to represent electron? If anybody asks you how to represent electron, what is the address of electron? If they say three possible quantum numbers are there: principal, azimuthal, and spin quantum. Magnetic quantum number. Now, what is this spin quantum number? Spin quantum number does not explain the position of electron, does not explain the address of electron. It will explain what actually, let me see. It explains spin. Spin nothing but what? Momentum, moving, isn't it? Let me see this spin quantum number can be represented by S and MS value. MS we can write it. MS or S. This S nomenclature we are using in the old books. In the old books it will be seen. But in the new books what happened? We are using MS. MS value we are using. It's proposed by what? Uhlenbeck. Other what happened? Goldsmith actually. Electron spins around its own axis while revolving around the nucleus of an atom. Whenever electron is revolving around the nucleus, what happened? It will spin around its own axis like this here. It may spin like this in the clockwise, or it may spin in this also, in anti-clockwise also. Like clock, if you observe what happened, all of you just watch the clock like this. 1, 3, so 12, 3, 6, 9. Now clock always moves like this. This is called what? Clockwise direction. What is anti-clockwise direction? Like this. 12, 3, 6, 9. In this way. Bit move like this, what happened? This is called anti-clockwise. Anti-clock. This one is what? Clockwise direction. Now any electron will spin like this on its own axis. On its own axis like this. It will spin like this on its own axis. Let me see all these diagrams, everything. I will show that one, all the diagrams. An electron has not only mass and charge, but also spin angular momentum because of spinning. Because of spinning, what happened? It will get an angular momentum called as spin angular momentum. Let me see this one. Now that orientations we can write as in the values plus of and minus of. Only two values will be there. The spin quantum number MS spin quantum number will have only two values. One is called plus of, other is what having minus of. Only two values were having. Plus of means what? Clockwise direction. Minus of means what here? Anti-clockwise direction. Let me see this one also. In each orbital, I already told you, in each orbital we have how many electrons here? Only two electrons. One is upward direction, other is what? Downward direction. You can place how many electrons in a orbital? Only two electrons we can place here. Now one will be upward, other will be downward. This will show upward direction. That means S is equal to what we can take here? Plus of for what? Clockwise. Clockwise spin, we can take upward direction or plus of, isn't it? This is, remember, you remember, always remember, clockwise spin, upward direction, plus of. But anti-clockwise spin, minus of, downward direction, anti-clockwise. Anti-clockwise. Plus of means what happened? The spin quantum number, if it is plus of, upward direction, clockwise manner. If spin quantum number is minus of, downward direction, anti-clockwise. Because of spinning of electron, it produces some momentum. That momentum you are calling as spin angular momentum that can be calculated by this value. This formula we can easily. For example, S is equal to get the values. Substitute here, you will get the one. But generally what happened, we have more number of electrons there, no atomic. So you will take this formula, generally will take this, will get in the 12th class, you will get this formula. Here in this what happened, I will show you this n value also, total spin. Now total number of spins we can take n value, that I will show in the next slides. I will show that. Two electrons that have different ms values are said to be opposite spins. If you are having what like this, they're opposite spins. Opposite spins here. One is having plus of, other is having minus of. An orbital, any orbital can accommodate how many? Only 2 electrons. Only 2 electrons. More than 2 electrons are not possible. To account the stability of the 2 electrons in orbital should possess opposite spins. Most of the cases what happened in orbital, the electrons are always in the opposite spin like this. That is the way what happened, they will get the stability. One is in spinning, other is in parallel, other is what anti-parallel like this. Now you see it like this. One is in clockwise plus of, other is in minus of, like this it is. You can also show like this also by showing what half arrow also. Paired spin we can call. In this way also we can show parallel spin. Parallel means in same direction. Same direction. These are in opposite direction. These are in opposite direction. Same and opposite direction there are. You can show like this also, how it is moving. You see, the electron is moving in which direction? You observe here what happened? Clockwise direction. Is it moving in clockwise direction? Now it is moving in anti-clockwise direction. Anti-clockwise direction. Like this here. But actually, I mean, I have changed the position here. South pole, north pole, I just completely what happened? Change here. Isn't it? So this is called what? Clockwise spin. This one is called anti-clockwise spin actually. That means the pole once you change what happened, the values also will be changed here. That means this arrow will be changed actually. Now what happened here? One is having plus of, other is having minus of. Plus of and minus of is equal to ms will be what here? 0. So for example, for this one is plus of, this one is minus of. Now total spin is equal to how much here? The total spin is equal to 0 only. Total spin for in any orbital will be 0 generally. It will be. Plus of and you see clockwise. This one is anti. Plus of and minus of. This way also we can show magnet. Magnet. Electron is moving. See how it is moving here? In this way it is moving. How it is moving? In this way it is moving. Clockwise and anti-clockwise, isn't it? It is moving like this actually. Ms is equal to minus of, ms is equal to plus of, how electrons are moving here. South pole, north pole, if you observe here, in this way the electron will move actually. In examination, nobody asks to draw this type of diagrams here. Two electrons have similar spin, that means plus of and plus of, they are called parallel spin, like this. Like this they are called. They are called parallel spin, plus of and plus of. Otherwise you can show like this also. Like this also. This will be minus of, again minus of. This will be called parallel spin here. So they may present in same orbital or different orbitals also. So now you observe one diagram here. Clockwise plus of parallel spin. Anti-clockwise parallel spin. Like this also. Now you observe here actually the 3 electrons are not present in the same orbital. For example, this is px, py, pz. These 3 electrons present in the anti-clockwise in the parallel spin here. Isn't it? Anti-clockwise in parallel spin. That means what I am saying here, the electrons may present in the same orbital or in different orbital, but maximum of electrons in the orbital will be only 2 only. Maximum will be 2 we can place. So we can calculate the spin for the, what is the spin for this one? Minus of, and here also minus of, and here also what? Minus of. Well, 3 minus of, minus of, minus of, minus of. Total spin will be how much here? Minus 3 by 2. Minus 3 by 2. The total spin will be minus 3 by 2. This one will be minus of, will be how much here? Minus 1 at least. The total spin will be minus 1. Isn't it? This one will be plus of and plus of. The total spin will be is equal to plus 1. That means we are calculating the total spin of a given atom by using what actually? By adding all the spin of electrons like this. Clockwise spin. How we get here? Clockwise spin. plus, isn't it? It will right here. Plus of. So plus 3 by 2 we get it. So all these 3 electrons in orbital have similar type of spins. There's parallel spin. So they are having what? Parallel levels. This is about what actually quantum numbers.